Hello friends, welcome to my channel at the Monster. I would like to start with the very first video onto this Kubernetes part, basic part one, and today we'll discuss about the very basic introduction onto the Kubernetes. Okay, so let's start with that. So first of all, what is Kubernetes? So Kubernetes is a open source container orchestration platform, okay, which orchestrates the containerized applications and workload. Okay, so basically Kubernetes is not something like a cloud or it is a storage and all that. It is not like that. There are many myths, okay, and there are many like a misunderstanding into the IT people that Kubernetes is a cloud provider or it is a storage tool. Okay, it is not. Okay, it is a simple container management tool. Okay, open source container orchestration tool. So why I'm saying orchestration, because it manages not even the applications, okay, but it manages all the like entire life cycle of the product or the application. Okay, so it will manage the upscaling, downscaling. Okay, it will manage the infrastructure. It will manage the uh, basically entries point. Okay, it will manage the uh, basically the life cycle of the like a pod, right, and many other things. Okay, so that is the reason it is a basically container orchestration tool. Okay, so it will basically manage uh, the automatic healing part of the application as well. Okay, provided that we have a basically healing capability enabled or maybe developed inside the applications. Okay, so Kubernetes is a open source orchestration container orchestration platform. Okay, now this container orchestration platform is basically managing all the containerized application. Okay, so when I'm saying containerized application, it means all the applications which can be deployed into the containers, for example Docker, okay, and maybe any another container technology. Okay, so any application which can be deployed into the container that can be easily managed or orchestrated by the Kubernetes. Okay, so it will manage all the replicas, daemon sets, pods, lifecycle, networking. Okay, downsizing, upsizing, everything it will manage. That is why it is a orchestration platform. It is not a simple tool. Okay, it is not a cloud. It is not a cloud provider. Okay, it is not something like a public cloud or a private cloud. No, it is a container orchestration platform. Okay, it is an open source system for automating deployment, scaling, and the management. Okay, so you can deploy the changes into the application easily without any downtime into the Kubernetes. Okay, so Kubernetes has many flavors, right? If you go to the cloud, right? For example, AWS or maybe Azure, right? Or maybe GCP. Now, in these cloud providers, they have their own services, okay, for the Kubernetes, right? So if we have basically AWS, then there is a EKS, okay, Elastic Kubernetes Service. Now, what they do, they have given the paid services, okay, and you can deploy your application into the EKS service. AWS will provide you the Kubernetes servers, okay, the entire cluster, okay, and then you can deploy the applications on top of that. Okay, so it is basically a commercial offering from the cloud provider. But Kubernetes as a basic, it is an open source system, okay, developed by the Google, and they have made that as a open source. Okay, so it is a free. We do not have to pay any kind of a license for that. Okay, all this commercial offering, right? Obviously, there is a pay. Obviously, there is a cost involved in that. But then, in case of the open source, it is a basically a free license. You can just download that. You can deploy into the servers, and then you can start using that. Okay, so that is the reason it is an open source system for automating deployment, scaling, and management. Now, little bit onto the, if you see this diagram, little bit onto the basically workflow onto the deployment side. Okay, so let's say there is a basically a system. Okay, now let me explain what exactly I'm trying to mention here. as a part of the what is Kubernetes perspective. Okay, and why Kubernetes is very important in terms of deployment and managing the containerized application. So I just wanted to give you some kind of a like a basic history, and then how it came a long way to this kind of entire journey. Now, if you see into the traditional deployment, right? Now, what happens? There is a hardware, there is operating system, and there is a so many applications on top of that, right? So just take the bare metal hardware, install any kind of operating system, whether it is Unix, Linux, or Windows. Okay, be it any operating system, and then we used to deploy the applications on top of that. So that is like a basically traditional deployment, right? For any software or for any applications, right? Now, what happens that in case of this traditional deployment, we faced or we had many challenges, right? Obviously, there is a cost. That is the first and foremost kind of a challenge, right? Because we need to buy the hardware, there is operating system license, right? And then we have application licenses as well, right? And typically, this deployment usually used to take many hours, right? Okay, and obviously with the downtime, okay, because we used to have many like a kind of a monolithic kind of applications, right? And then we used to deploy these applications onto this operating system, and then obviously we need to handle many things like infrastructure, networking, database, APIs, middleware, right? Front end, everything we had to handle. So obviously there was a downtime, right? And then obviously the hardware cost, okay, because we used to procure the hardware, okay, from the companies, right, and then deploy the OS on that, okay. So apart from this cost, the other challenges was the resource management. Resource management was very like a crucial, okay, and that was not effective, by the way. Okay, let's say for example, my application need only, let's say, 500 MB of RAM, okay, and maybe some millicores, okay. Then even though my application need very small amount of these resources, I have to still buy a very large machine. Why? Because I cannot define this granular level of resource management at the lowest level. I cannot define that, right? Because at that time I was not having any kind of a platform, right? What we used to do, we used to just deploy the hardware and then deploy the OS, okay, and then take some kind of a machine, okay, that is like a very like a big machine, like an elephant size machine, maybe some kind of 8 GB of RAM or maybe 32 GB of RAM, whatever it may be, right? And then some kind of a like a 4 cores or maybe like 8 cores and all that, right? But my requirement was very minimal. My requirement was very minimal. Okay, I just need a, let's say, 256 MB of RAM. Then why should I procure this many amount of resources? Okay, does it make sense, right? And obviously all the resources will go on waste. Okay, so that's the reason in case of the traditional deployment, the resource management was not at all effective. And because of that, that specific thing got changed. And then it was like a very kind of a messy kind of a stuff. Okay. I am talking about this scenario probably 2 decades ago, right? That was the case, maybe in early 90s or maybe late 80s and all that, something like that, right? So because of these challenges, a technology evolved, right? Okay, and then we started thinking like what could be the better option so that we can nullify these kind of pitfalls, nullify these kind of problems, and then get going. Okay, so as IT evolves, right, and then we started thinking like what could be the better options and all that, right? Then we moved into the virtualized deployment kind of a environment. So virtualization technology came into the picture. Okay, and this virtualization technology solved many kind of a problem. First of all, it solved cost problem. Second, it solved the resource management as well, right? Okay, at least up to some extent, not maybe at the granular level, okay, like a very at the component level or maybe sub-component level, but at least I could define certain kind of basically resources at the certain level. Okay, so that's the case. So hardware is coming into the picture, then operating system on top of that, okay, and then there is a hypervisor. So now what is the main use of the hypervisor? It will basically manage the resources, the kernel, the file systems, right? All the communication between hardware and to the guest operating system and to the host operating systems and all that, right? And it will basically inherit all the properties of the host operating system and give you the another operating system on top of that. Okay, so that was basically a the scenario, right? So hypervisor really helped us a lot. It gives you an opportunity to create many more machines, okay, like a virtual machine 1, virtual machine 2, okay, and then basically deploy many VMs on top of that. So you can, so basically in case of the virtualization, what happened? We have a big monolithic or maybe bare metal kind of hardware. We will deploy the host operating system, okay, that can be anything, Windows, Linux, or Linux, whichever is of your choice, and then deploy the hypervisor. Now there are many hypervisors in the market. There are open source, there are paid, there are licensed one, commercial offerings and all that. We have many things, right? You can deploy that hypervisor as per your need. And then using that hypervisor, now you can create the VMs, virtual machines, right? Virtualized machines, okay? Those machine doesn't have any kind of a physical existence, okay? But underlying hardware or underlying operating system, they have a physical existence, right? So that's the case. And these technology, they came from the VMware. Okay, so that's the case. Now, because of this operating system, hypervisor, and the VMs part, we can start, like, because of these kind of a virtualization, we could start creating many virtual machines, okay, depending on the capacity, right? Let's say, for example, if I have a, let's say, a bigger hardware and big storage also available, then we can, let's say, for example, maybe I have a, let's say, multi-core machine and maybe like a terabytes of like a RAM or memory, right? Then I can create small VM. Okay, I can divide those resources into the smaller chunk and then basically create the virtual machine. And once the virtual machines are created, I can deploy the applications on top of that. Okay. Now, what problems virtualization solved here? Virtualization solved the problem of first and first cost. Okay, because I can create any number of virtual machines, right? So in the only cost which I have to bear is the hardware cost and the operating system cost. That's it. Then I can create any number of virtual machine. Okay, that is one problem I solved. Second problem, resource management. I can create small virtual machine, right? So in traditional deployment, what used to happen? I used to create the bigger virtual machine, sorry, bigger machines, right? Let's say 8 core or maybe 16 core or whatever. But now I can create very small virtual machine. Let's say one virtual CPU or 2 GB of RAM. Okay, very small machine I can create. Okay, so up to certain extent, I could solve the problem of resource management because of this virtualization. So we solve that problem, right? Resource management. That is one. Okay. Second, the third problem which we solve is I can destroy or I can create this virtual machine in a minute, right? So no need to procure some kind of a bigger hardwares and all that, right? I mean, at least as a bare metal, yes, I have to buy that hardware. Okay, but virtual machines are very kind of a kind of a destroyable. I can create anytime, I can destroy anytime, right? So capital investment or the capital cost was reduced because of that. Okay, okay, so that is one. So let's say, for example, if I need a virtual machine for only 8 hours, right? Then I can do that using the virtualization technology. I can create the machine and then I can work, I can do my work, I can do the development, deployment, whatever it may be, right? And then I can destroy at the end of the day, right? So it is very easy to manage, okay, because it is a virtualized machine. Fourth problem which we solved is like virtual machine I can create anywhere across the globe, okay. Okay, so it's very basically it's very easy, right? Let's say, for example, I have my data center, okay, into the some maybe US locations and all that. I can create that virtual machine at that location, and then I can go ahead from that point. Okay, so virtual machines are basically I can access and I can create and I can deploy the applications. So that is the benefit of the virtualization deployment. Now there are certain disadvantages as well. There are certain disadvantages as well. Now, in case of these disadvantages of the virtualization deployment, another problem is like I cannot go anywhere in the location perspective. Okay. For example, if I have my, let's say, hardware or maybe the location at one place, I can create the virtual machine at that place only. Okay. I cannot access remotely. Okay. So that is also another problem. Second problem is like I cannot still go to the granular level. Okay, I can go to the virtual CPU, one virtual CPU, 2 GB of RAM, but then still there is no any way where I can say that I need just a 256 MB of RAM or maybe 200 milli core. for my application. Can I define that in the virtualization environment? No. Okay, so this is another challenge. Another problem is like, again, we solve the problem of cost, but not that much. Okay, because we have to bear the cost of the hypervisor if it is a paid one, then obviously hardware, storage, and everything, right? So that granularity I'm still not able to achieve, which I'm still thinking of. How can I solve that problem? Okay, so that is one. So point here is like, even though virtualization did a great job, right, by bringing all these features, improvements, and all that, right, still there is a room for improvement, and that's the reason containerized deployment using Kubernetes came into the picture. Now, using Kubernetes, what I can do, I can deploy any application on any machine, okay, which is a compatible. That's it, and very on the very lowest cost, a very cheap kind of a cost. Okay, I can destroy that container anytime. I can destroy that pod anytime. I can define my resource at any time, right? Whether it is a 100 millicore or 50 millicore, I can define. Okay, I can define any type of memory, right? It's very easy. It's very flexible, right? And because of this Kubernetes, this is achievable. So that's the reason here, in case of the container deployment, we have a hardware, we have operating system, and instead of hypervisor, there is a container runtime. Okay, and then container runtime is nothing but the actual container engine. That is nothing but the Docker. Okay, the Docker daemons and all that, right? And we have a basically system on top of that. So using that container runtime, I can deploy the container one, container two, or any number of containers on top of that, right? So point here is I can deploy all the containers, any number of containers depending on the capacity, and then and then access my application. Okay. So only requirement here is the application has to be containerized. Okay, it is a container compatible. It has to be basically OS compatible, and that's it. Okay, and I'm done, right? So point here is like, because of these container kind of a containerized kind of a deployment, all the problems are resolved. Resource management, cost, compatibility, platform independence, right? Everything, and obviously all like a basically like a public cloud providers and all that. They also have their kind of offerings, and then I can deploy application and at my choice. Okay, so that's the point. So this is basically a very basic thing. I just wanted to like I mention here, what is Kubernetes, okay, and what value add it brings to the table, okay, and basically what is the use of that, okay. So I hope you like this my video. I request all of you to please once you like this video, subscribe to this channel, and then basically see for upcoming videos as well. Okay, do share your likings and put your some comments if you want any kind of improvement areas or maybe more detailed kind of information or a description. I would love to do that. Okay, and basically give more information on top of that. Okay, so thank you very much for this video, for like listening and watching this video, and then probably stay tuned for the next videos. Thank you very much.